For blockchain is the technological solution, but also as a social solution. Right? The social science is involved as well. It comes down to trust. But at what level are you using? So, I think we've got to break it down to multiple chains because not all chains are created equal, right?
Welcome to the Hacker Noon podcast. I'm your host, Trent Lipinski. In this episode, we sit down with Greg Osuri. He's working on Akash Network, which is a decentralized protocol for provisioning, scaling, and securing cloud workloads. If you're in the cloud computing industry or work in DevOps, this is an amazing episode about what it takes to launch a decentralized network. I'm here with Greg from Akash Network. Hey, Greg, how's it going? What are you working on?
Hey, Trent. Good. How are you? Working on a decentralized cloud infrastructure network that aggregates computing power from disparate sources and creates a new super cloud.
And you're using blockchain to be able to do this, correct?
Yeah. Little background. I've been a programmer for 22 years, and in which I've designed scalable infrastructures that scale up to 1 billion transactions a day. That's about 11,000 transactions a second. Built designed large-scale data center infrastructures for Fortune 50 companies such as Verizon, Sprint, Blue Crosses, and whatnot, and builds and manage large developer communities across 50 cities around the world with about 150,000 developers as the founder of AngelHack, right? For what's worth, I've been placed as top 5 Golang programmers in the world on GitHub for my contributions to libraries that are used by projects like Kubernetes, Ubuntu, and whatnot. And so companies usually bring me in to solve critical scalability issues. And one of them happened to be a company called Demandbase, where I was there for 2 years, and I was tasked to solve 3 major challenges they had at the time. The first challenge was to design an infrastructure that can deliver up to 1 billion transactions a day. Do so that the payload renders within 50 millisecond latency. That's about 1/20th of a second, right? That's the end user latency. And number 3 was to design a deployment system that can deploy to over 2,000 nodes across the world without causing any downtime. And they release these new patches almost on a daily basis. So I was able to do number 1 and number 3 fairly well. But when it comes to number 2, the low latency problem, that was unachievable on the cloud because the cloud doesn't really optimize for latency, but they optimize for hyperscale. The global coverage that's required for a high performance workload doesn't exist. I gathered a team of world-class engineers, my co-founder, who happens to be a security researcher, a scientist. He invented network protocol fuzzing. He has a patent for it as well. I teamed up with him and created Overclock Labs to solve the second issue, in which we created an operating system called DISCO. DISCO stands for Distributed Infrastructure for Serverless Computing Operations. It's an operating system that allows developers to operate across cloud providers or providers in general seamlessly, both with application as well as state. So the idea is anybody can use this OS and get the replication, solve for all the difficulties of maintaining a global infrastructure.
And this is regardless of cloud provider, right? They can run this operating system pretty much on any cloud, and then that allows them to be able to connect between cloud providers essentially by using this unified operating system and code base.
Correct. So it handles both the application ephemeral states as well, stateless and stateful applications, right? So it also happens to be the world's first container native cloud operability solution kind of thing. We were deploying this to customers, and we noticed a very critical problem with the cloud today, and that happens to be with scalability. And the reason for that is while the amount of the data processing needs are doubling every 2 years, the processing power hasn't been catching up, right? So we're not having enough server capacity to process all this data, and that's translating into costs being increasing. Why? Because because the modern access to modern infrastructure is safeguarded by the cloud infrastructure providers, right? The three providers, if you want to.
Centralized. Yeah. You've got
centralized.
Yeah, Google
Right?
Cloud, AWS, you've got Azure, a handful of a few major cloud providers. You've got OVH and a couple other smaller ones, but
Yeah, about 21 hyperscale providers, out of which three providers have the majority of the market share. About 2 years, we're going to see 80% market share, right? So it's definitely the way the direction it's heading is to have an oligopoly in the cloud, we call it, right? And that's a problem generally with centralized systems. But more importantly, what's coming down to is they are being gatekeepers. They are not allowing the cloud to scale. And another interesting fact we discovered was that 85% of server capacity sitting in colo on-prem data centers remain unused. I'll give you an extreme example. Intuit is a company behind TurboTax. On a tax day, they run at 97% utilization. Come next day, it drops. So for about 9 months of the year, they run at almost 3% utilization. So considering a shelf life of a server is about 3 years, for we're talking about 21 months, they're essentially not using those servers, right? So on one hand, you have this massive scalability problem. On the other hand, you have this massive latent supply. And then we realized we need a radical, different way to sort of solve this scalability issue for the cloud. And that's how the idea behind Akash came about. By using decentralization, we can effectively create a system where there is no middleman. We effectively turn every company with capacity into a cloud provider, walking the same path as Amazon took, if you remember, in the 2000s, when they entered the cloud market. They were not the first ones to enter the market, right? There were VPS solutions, you had Rackspace, and a whole lot of providers. And it was a fairly crowded market, if you think about it. But Amazon had this massive latent supply, and they wanted to monetize on this latent supply, and that's how they began. So we're effectively, by kind of walking in the footsteps, we can solve this problem. But being 2008, we can solve it way better and not riddle this new provider with all the problems the centralized providers came by decentralization, right? So, and also, and we realize we're not the only decentralized cloud provider. I mean, there's Ethereum, there's EOS, and pretty much everyone is trying to solve this problem because the world over, we recognize this is a problem. And we looked at the decentralization solutions, and they fall into another bottleneck with scalability, right? For example, Ethereum network, it costs about $13,000 to get one megabyte of memory on Ethereum. It's terrible. And I mean, I love Ethereum, but it's just not scalable, right? And if you look at EOS, which is supposed to be the modern Ethereum killer, it costs about $2,500 per megabyte of memory on EOS, right? So we're talking about a floppy disk costing $2,500, right? So obviously the problem, we looked at these architectures, the problem happens to be they all adopt a monolithic and a homogeneous architecture with an assumption that all the applications have same exact needs, right? So any smart contract is effectively a program, a function, right? You deploy this function on this computer, and by treating all functions as homogeneous, you effectively create a very inefficient pricing mechanism, right? So then we realized in order to solve, so Ethereum and EOS are not solving this problem. In order to solve this, we need to really decouple all the elements of a decentralized network. And that happens to be the four fundamental elements of any workload happens to be bandwidth, memory, CPU, and storage, right? So by decoupling the application layer and the base layer, and using a mechanism to provision this base layer independently of the application layer, we can solve the scalability issue. And that's what we're doing with Akash.
Heyo, you got a great tech story you want to get published? Maybe something about bots taking over Twitter or how Bitcoin actually works? Or maybe you just have a story about how to build a great software or a great team. Get your expertise published on Hacker Noon. Email us stories@hackernoon.com, and a real human will review your submission.
So you're taking the same advancements and the same technology and the same concepts that have been applied to centralized scaling, but you're now applying them to a decentralized system that takes all of those things into consideration as well.
Right. So if you look at the benefits of a decentralized system, like as a developer, why would you want to develop on a decentralized system, right? What's your appeal? For me, it's about censorship resistance and fault resilience, right? So the idea that I can push a workload or push a job or a function and forget about it. It will run no matter what, as long as I have tokens to pay for it, right?
Yep.
And that is the essence of a decentralized system. There's no single point of failure, and there's nobody that can take you down, right? Yep. So keeping that in mind as to why we are designing a decentralized system, starting from scratch, while keeping those goals and designing a system is super critical, instead of going and falling in the same path that Ethereum did. Ethereum does a great job at making the developer experience great. But if you really look at really go a little more technical, if you look at a smart contract, right? A runtime for a smart contract is essentially one instance, right? So that correlates to the number of users you have. If you can achieve the same scalability in terms of runtime and not have the same cost using containers, is what we're doing.
And essentially, you're building the infrastructure for a decentralized internet, whereas Ethereum is more like it's really, as you said, it's a monolithic application structure. It's at the application and it's definitely an interesting proof of concept for a decentralized application layer. It definitely provides that groundwork, but in terms of being able to build scalable applications that function the same way that centralized applications function, in the same way that we're used to using Facebook and Twitter and the banking services that we're used to today and those kind of things, it can't compete. It's not even close. You said, all right, I'm going to go solve the problem of let's go fix the infrastructure layer that decentralization needs to actually function properly. And then ultimately, can people build on top of what you've built, or are you planning to build additional services and features and functions eventually?
So this is an ocean to boil, right? And we cannot do it ourselves. So it's a protocol with multiple layers on top of that. So first layer is the base layer, which essentially solves for these 4 fundamental units. And then since we're doing containers, the idea is we can allow any runtime to run on this base layer. Now, are we going to do a smart contracts platform or a serverless platform, we call it, right, for easier understanding, or someone else? That's still in play, but we've been looking at various different languages to achieve the serverless functionality. Look, remember, we built something serverless 3 years ago, and that framework we built in the first version was very opinionated, right? So the challenge is, how do you design something that's not opinionated, at the same time easy to use? That's a very challenging proposition, right? Yeah. So to answer your question, are we going to build the most optimal serverless framework on a decentralized network? Maybe not, maybe not. But since this is open, anybody can build anything. So the idea is to have the ecosystem come up with solutions, or us eventually, maybe in the future, come up with solutions, but be open in the development process. Every layer is what our current priorities are.
Yeah, and in the interim, it sounds like with what you've already created and built, if you're a company or someone who has a data center already and you're not fully utilizing that, you can install your software, and now are they earning coins, tokens, rewards? Is there incentives for giving up their compute and bandwidth and all of that? How does that work?
Yeah, absolutely. So there's definitely, the incentive for giving up your infrastructure is you get monetary value, right? So the way it works is the provider installs the Akash agent, which is essentially an operating system, on their nodes. And upon doing so, the node registers with the network, and the tenant finds their workload in something we call a SDL file, or stack definition language, where you can get to be pretty creative in terms of your deployment. You specify your resources as to how much memory bandwidth and whatnot you need, and that is posted to the chain along with specification of how much tokens you're willing to pay for that job, right? And then the providers detect that, And there's a real-time auction that happens, a programmatic auction. The lowest bidder usually wins the auction that matches all the requirements. Once a lease is created, this is the most interesting part of Akash, and that's not very common, is we do an off-chain model. So once a lease is created, the provider and the tenant go off-chain into a private peer-to-peer network wherein the assets get transferred. It's completely isolated from the rest of the chain. So by moving away from the chain, we can effectively achieve the scalability we need during the runtime, right? And
reduce latency between the two, I'm assuming.
That depends on the requirements of your position, of your location affinity and whatnot, right? But we do provide those controls for you, so that's the best part of it. And the idea is to not have any opinions and have the developer have all the opinions, right? So we're building something for developers to build other things. Essentially, we're not building for protocol developers to build amazing protocols on top of Akash. And the third phase is of obviously settlement. So as the workloads are being run, the payments happen almost on every block time, that's every second, and that's how it works.
Very cool. So
and we do have a testnet live right now, which I'm super excited. GregOsuri.com is my blog is hosted on the testnet. We are rolling out the testnet to developers. So if any of you want to play around with it, let me know, and I'll be more than happy to give you access.
And this is one of the first web applications that's being powered by a completely decentralized network. Isn't that correct?
Yeah, this is the first decentralized cloud that can run a full functioning web application, be it Ruby, Python, Node, doesn't really matter.
Yeah, which I mean that's critical, because it allows these developers to be able to use the same programming languages that they're already using today for their centralized applications. You're essentially creating a bridge for them to move into a decentralized cloud and allowing them to still use the programming languages they're comfortable with, but by approaching it at a developer operations level in a totally different way. That's what's so unique about what you're working on, I think. And I've been waiting for a project to kind of merge DevOps ideology and bring that to the blockchain and do something exactly like what you're creating, because I think there's a total use case for it. Because right now where we're at with the blockchain, it's about infrastructure. At the end of the day, it's about getting developers, bringing them to decentralization, setting them up on decentralized clouds, getting their hands on these technologies, but doing so in a way that they're still comfortable, so they don't necessarily have to learn 100% of the new system. They can use code that they're already used to using, web applications, web stacks, tech stacks that they already know, but get to use them in a way that they didn't get to use them before, and then get all the advantages of decentralization.
Heyo, you got a great tech story you want to get published? Maybe something about bots taking over Twitter or how Bitcoin actually works? Or maybe you just have a story about how to build a great software or a great team. Get your expertise published on Hacker Noon. Email us stories@hackernoon.com, and a real human will review your submission.
Essentially what it is, right? So I think we need to allow developers to get freedom for a single point of failure first. That's super important. And then, we definitely need to create frameworks to improve the smart contracts mechanism. And don't get me wrong, smart contracts are great. The constraint-based design, they're very constraining, right? I mean, there's a reason for it. If you don't constrain, you can't have abstractions that allow you to run an execution. So the difference between Akash and the rest of the blockchains is you end up doing a lot more work as a developer than what you would otherwise do on Ethereum, right? Ethereum is fire and forget a contract. Whereas on Akash, you actually end up, building containers and whatnot. So that's the, trade-off between ease of use and power, right? So there's always a trade-off, right? So we're optimizing for power and scalability first, and then we'll build the other layers that make it extremely simple. Us or someone else, we don't know that.
Yeah. And then most of this is open source, right? So people are going to be able to essentially go build their own applications and different use cases. And then you're going to start to build a developer community. And once you start getting different contributions, and then it's going to grow, and the users and the developers are going to ultimately kind of decide the future and what that looks like.
Yep, absolutely. We're a developer focused organization and a developer first organization. So If you look at all our tools, almost all of them are open source. I don't think we have anything closed. And I've been writing a lot of examples on how to sort of like build upon top of Akash recently. So if you check out our GitHub, you'll have an idea. We're also releasing automation scripts so you can run your own Akash, your own instance of your testnet if you want. I mean, we're doing all kinds of cool things. Yeah.
So if I was an application developer and I wanted to take advantage of this, how would I get started?
The two ways, right? So first is you can essentially get on our testnet. As long as you have tokens to pay for it, you'll be able to access the testnet. And or you can run your own testnet, a multi-node setup by going to Overclock's GitHub and looking at Akash, which is a little more work to do, right? So from a friction standpoint, the best way is access the testnet.
Heyo, you got a great tech story you want to get published? Maybe something about bots taking over Twitter or how Bitcoin actually works? Or maybe you just have a story about how to build a great software or a great team. Get your expertise published on Hacker Noon. Email us stories@hackernoon.com and a real human will review your submission.
And so where are you at as a business? Like, did you do an ICO? Have you avoided ICOs? Like, what got you to this point? And then what's the next step?
So we raised equity capital a while back, led by Crunch Fund. And we did a small private token sale for our existing investors, our equity investors, and a few friends and family network, right, in our network. We are going to do a token generation event and token sale following that fairly quickly. And we didn't want to do a token sale until we have a product out in the market and a product that people use. And
this will be a utility token, just to clarify.
Correct. It is a utility token. It is used for gaining access to computational resources on the network, right? So that's the purpose of this token. It does not represent equity in a company or an asset.
Yep. And I mean, that's essentially the Ethereum model, which the SEC said is a utility token.
Correct. We are optimizing for consumability of the token. So problem today with deflationary tokens are obviously not used for paying. Like think about like EOS network, right? The RAM market is just ridiculously expensive. We're optimizing to be developer first and not investor first. So we very strongly believe if you create something consumable by developers and usable by developers, that's the only way to win the market, right? So if you look at EOS network, no one's building on EOS because it's too expensive to run. I mean, I'm not paying $2,500 per megabyte of memory. It's not ridiculous, right? So,
yeah. No, and I mean, that's the challenge with a lot of these early blockchain projects is they, like I said, I almost think of them as proof of concepts because they just didn't take scalability into consideration, which ultimately means that they're going to hit bottlenecks. I mean, it doesn't mean that Ethereum down the road isn't going to innovate and maybe acquire other companies and implement some of their technology to be able to give them scalable solutions. But at the end of the day, their bottom line infrastructure is just not scalable. And it wasn't designed to scale. So, there's definitely a major use case for what you're working on and being able to create a decentralized cloud solution to be able to have that scalability and enabling developers to use their already existing development languages and their existing tech stacks to be able to do so. And by leveraging containers, you're enabling anybody to essentially run pretty much any major application or tech stacks in a decentralized cloud. So that it's a game changer.
Thank you. I mean, I was really hoping EOS being just launched recently, EOS would address some of the problems Ethereum has. It definitely does address to a certain degree, but it's riddled by the same exact nature of the problems, right? I mean, in a different form, but at the end of the day, it's the same problem.
Heyo, you got a great tech story you want to get published? Maybe something about bots taking over Twitter or how Bitcoin actually works? Or maybe you just have a story about how to build a great software or a great team. Get your expertise published on Hacker Noon. Email us stories@hackernoon.com and a real human will review your submission.
Well, and it sounds like you're agnostic even from a coding standpoint and even from a governance standpoint where like EOS is it's got capitalism modeled into it in a way that basically the person who holds the most amount of tokens or coins has the most amount of vote and power and say, which is very much how like the US dollar and, the traditional system works. So I understand why they went that direction with their governance, but, that could impede initial, adoption of their platform, and it could interfere with how people use the platform. Where it sounds like from what you're building, you're just not even playing the governance game. You're letting people, you're letting the code speak for itself, letting people build what they want to build on top of the scalable technology that allows them to use the blockchain in a way that's logical and gets all the advantages of decentralization, but without the politics of some of these other blockchain systems.
So blockchain is a big database, right? So let's break it down. So using blockchain, the data structure of the blockchain, the advantages are, of course, decentralized consensus, right? So the idea is anybody can write to it as long as you have a private and public key. When it comes to consensus of actually writing to the chain, that's a very hard problem. I think US with their delegated proof of stake has a good solution. It's just implemented poorly, right? So
yeah, I think we agree on that one.
Yeah, delegated proof of stake is a good solution because it's sort of like,
it's a good model. It's just the way they implemented it. There's going to be challenges there, and it adds politics to an already technically complicated environment. So you've already got the challenges of this being new technology, emerging technology, and the adoption of that. But then you added a system that does involve a human level of politics that complicates things unnecessarily, in my opinion.
I mean, I think we use delegated proof of stake too. So I think it comes down to like, for blockchain is the technological solution, but also as a social solution too, right? The social sciences involved as well. It comes down to trust. But at what level are you using? So, I mean, I think we've got to break it down to multiple chains because not all chains are created equal, right? Correct. So it really comes down to like, just like how you would shard,
I think there's a book title right there. All chains aren't created equal. That's your next like Medium or blog post right there.
Yeah. So we use blockchain for our provisioning, right? For our provisioning of resources and settlement of those resources, right? Mm-hmm. But you're not, as a developer, you're not building on this blockchain. You're building on whatever chain you want to build on, or bring your own chain, right? So by decoupling consensus, by decoupling, by being unopinionated, and by achieving or like designing a system where you have multiple chains that does different things, you can create a truly decentralized system. So it's like, I'm a big believer in heterogeneous systems, right? I don't believe in homogeneous systems as scalable solutions, even though they simplify things from a design standpoint, but they're not scalable. Heterogeneous systems have to take into account the purpose and use case of individual, and we design around that. So that's what we're taking, the approach we're taking with Akash.
Pleasure having you on. Do you have any final thoughts?
I just want to make sure people understand Akash is a fully open source network, right? And the reason we're building this is to create a network or a cloud infrastructure that is not owned by anyone, but open to everyone, right? And we cannot, an individual standing up cannot take on Goliaths, right? I mean, this is, we're talking about Amazon, Google, Microsoft. The only way we can do this is together. I would really love to invite your community members to join our Telegram. You can find the link by going to our website, which is akash.network, akash.network. Telegram is t.me akashnw. That is t.me/akashnw. And we want to talk to developers, especially if you're a protocol developer or developer interested in decentralized networks, or anybody that wants to take on this oligopoly that we're seeing in the cloud today. Please find us, talk to us, and really we want you to use the platform and try it out. And if you want to make any changes, please send me a pull request. And I code almost every day. I'm more active on GitHub and Telegram. That's where you come find me.
Awesome. Well, thank you for building a solution to be able to do this. And thank you again for coming on the show.
Thanks so much, Trent. You have a good one.
This concludes another episode of the Hacker Noon podcast. I'm your host, Trent Lipinski. Please don't forget to subscribe to us on iTunes and YouTube and follow us on social media. You can also find us at hackernoon.com and podcast.hackernoon.com for more episodes. Thank you for listening.